Hi everybody. Welcome to my first actual stream. I've done a couple of screen tests before this, but it's nice to be here with you all. So I had tried to do a couple of more simish games. I'm a fan of F1 2013. I'm a fan of Euro Truck Simulator 2. But unfortunately, my little laptop isn't powerful enough to be able to play those games and actually be able to stream them to you at the same time. So I thought it might be nice to take a look at this game. So this is Human Resource Machine. It's a puzzle game that my girlfriend introduced me to a couple of years ago. And it's sort of a ad hoc introduction to assembly language programming. I should state, I am in real life a programmer. And so it was interesting for me to approach some of these puzzles where you kind of look at programming at a lower level. So let's dive in. I haven't played this game in a while, so I thought it'd be nice to take a look at it and give some insight from a professional programmer's perspective at the various puzzles that we have here. Okay, sorry about that. I made a slight mistake. Anyway, let's jump in. So we'll create a new profile. So we could be whoever. I'm partial to red hair, so we'll go with this person. Alright, and we'll dive into the first one. So this is the basic scenario of the entire game. Our job is to put together sets of instructions to complete various tasks. So for this first one, all we have to do is take everything from over on the left and get it into the outbox over on the right. So we can drag commands over to the right side and we can run them to see what that'll look like. So here we can see that we take one thing from the inbox and put it into the outbox, and it tells us that, oh, well, we had to do that 3 times because we expected 3 things. So at the moment, what we'll do is we'll just write this 3 times. We'll give it a try. And you can see that, we're running each instruction one at a time. Pretty simple. And we're done. We reached the end of our set of instructions that we put together, so we're done. Let's take a look at the second level. Right, so now we're given a new tool, and anyone who does a bit of programming knows that this is a pretty powerful tool, which is to jump. So you can see it says that with this new ability, we should be able to complete the assignment using only 3 total commands. So what we'll do is we'll do inbox, outbox like before, and this jump allows us to jump to a different line of the code. So you might think that this is actually just going to go on forever, and does that work? we're going to run out of letters in our inbox at some point, right? So we can see that now this is going to jumps to the top of our instruction set. Yeah, it's telling us you can make it go faster if you want, so we will. Notice the word initialize. So yeah, this is the other way that a program in this game can terminate, is once it reaches an inbox instruction, but there's nothing in the inbox. That's the other way that programs can terminate, or the algorithms can terminate in this game, is when you have an inbox instruction and there's nothing there. So ignore the inbox and just send the following 3 letters to the outbox, B-U-G, and they've placed some items on the carpet. And if only there's a way we could pick them up. Well, we notice we have this new copy from command, where we can say copy from, and then we can select where we want to copy from. So obviously we want B, and then we want to outbox that. We want U, and then to outbox that. We want G, and then to outbox that. So this is an introduction to a pretty simple tool where, you know, we as the worker, the processor, can also, you know, deal with things that are stored. We can have stored things that aren't just things that we're holding in our hands, like when we're going directly from the inbox to the outbox. We can also have things be stored on the floor and we can pick them up. And that's pretty similar to you know, working with memory registers when you're doing assembly level programming. Let's see what's next. Okay, so grab the first 2 things in from the inbox and drop them in the outbox in reverse order and repeat until the inbox is empty. And we have a new command called copy to, and we can copy to wherever we want on the carpet and they'll clean it up later, which is nice of them. Right, and obviously this is going to be necessary because we can only hold one thing in our hand at once. That's sort of obvious from the way that our worker holds it above their head, but we can only hold one thing at once. I think our manager wants to tell us something. Oh, okay, that's just saying that we can ask again if we want to. So that's fine. So I think what we'll need to do, we have a few free tiles on the carpet to work with. So we'll start by taking the first thing, and we'll copy it to some tile. And then we'll take the next thing, and then we'll just immediately put that into the outbox. And then that's the second thing, which should go in the outbox. The second thing from the inbox should go first in the outbox. And then we'll take the first thing that we had stored from the inbox and put it into the outbox. So let's try that. So it's 4-9, so we should be sending 9-4. So we store 4. We send 9 through immediately. We don't have to store it. And then we do 4. Right. And now since we need to do this for as many pairs as there happen to be 3, so we could write the set of instructions 3 times. But since we know that a program is going to terminate if we get an inbox instruction and there's nothing to pick up, then we can just write a simple jump loop that always jumps to the end of the program. So we'll run this a bit faster. So now we should see J and N, and now 5 and 2. Great. Hooray! Alright. So I'm going to turn up the volume and let you enjoy this cutscene.
Back to work, everyone.
Regions of the city continue to experience power failure. Local authorities are investigating.
Well, that's a little bit ominous. That's not what we'd be hoping to see. But let's move on to the next level. We'll forge on regardless. Okay, so for each two things in the inbox, add them together, put the result in the outbox. And we have a new command where we can add the contents of a tile on the floor to whatever value we're currently holding. Alright. So we'll take our first thing, and we have to store it, right? Because we can only hold one thing at once. So we have to store it. Because then we'll pick up the second number, and we'll add it to the first number. And let's see what that looks like. So we have 0, we'll store 0. Add it to 1, obviously that's 1. Right, so you can see that when you add it, then you're holding that value, right? So it doesn't automatically store it or anything, you're just holding it. And now we should be able to outbox the result of that. And again, we'll do a jump so that we go straight back to the beginning, and this program is going to terminate by us doing an inbox command and not having anything to pick up. That is 16. So 6 plus 4, we should see 10. Minus 8 and 4, we should see 4. And 6 and minus 7, we should see minus 1. Great. So again, pretty simple stuff. We're just adding numbers together. Nothing too complicated. I'm sure you can guess that the point of these early levels isn't to challenge you, it's to build up the tools that you're going to need to do the actual challenges. So now we have a couple of different paths that we can follow, but we'll do them in numerical order. I'll go to number 7. Your performance will be evaluated with extra scrutiny. Hooray. So send all things that are not 0 to the outbox. And we have this jump if 0 command. Well, that's interesting. So that's a conditional jump that allows us to go to a part of our code only if a value that we're holding is 0. So we need to send all things that are not 0. So obviously we need to start by taking the value. And then, in general, we just want to inbox outbox, right? That's our general structure. So, in general, the way that when you're writing at this kind of low level that you might structure your code is start by writing your general case, and then you can introduce these conditions. So, in the case where we pick something up from the inbox and it is 0, well, we just can go right around again, right? And we can pick something up again. If something's 0, then we'll just pick up the next thing. We'll immediately toss it in the trash and do the next thing. So 9 goes to the outbox, and then we see 0, and she should just toss it out. Yep, I like that little tossing out animation. Just toss it on the ground. Someone else will clean it up. Typical white-collar worker. Great. So you can see now the extra scrutiny that we promised is here. So it's looking at our algorithm in two different ways. How many commands do we use? And then how many steps? And it might not be obvious what that means. But really it's how many times does it have to execute a particular instruction in order to make its way through our algorithm, given whatever inputs it'll generally throw at it. That might seem like the same thing, the number of commands and how many times they're used, but we'll see later as we get into more complicated structures that those are actually pretty different. So let's take a look at 8. I wonder why it's on a different branch. It's for high-performing employees only. I think that is me. We'll see. You're late. Extra scrutiny again, alright. Oh, that was because it was a branch, so we could have come here first. Alright. So for each thing in the inbox, triple it and outbox the result. Okay. So obviously, we need to store things in order to add them. So we'll start by taking each thing from the inbox and storing it. And then what we'll do is add it to itself. So we can see what this looks like just by itself. We take 7, store it, add it to itself. Right? Adding something to itself obviously is the same as multiplying by 2. So to multiply by 3, we'll just add it to itself again, and that should be our answer. So that'll constant. And we will do this for as many things as there are. So 3 makes 6, makes 9. Yeah. Minus 7 makes minus 14 and minus 21. We'll speed this up a bit. You can see that we have a 0 coming. Now, obviously, it's going to act exactly the same way here. But this is a thing that becomes tricky in later levels, is dealing with the fact that you might have a 0. So we'll see what that looks like. Great. Looks like we have the optimal solution. Okay, so for the moment, I hear my dog wants to go outside, so I will be right back. Okay, sorry about that. I have a young puppy, so she goes outside every once in a while. So, alright, let's look at level number 9. Only the zeros. Detail up to you. Oh, we can do whatever we want with the other things. Alright. So, I think this is going to look much the same, right? So we're going to... Our general pattern is... Well, if we consider 0 the special case, then we're going to be inboxing, outboxing. But if it's 0, right, then we do want to do that outbox. Otherwise, we don't, right? Or no, I'm sorry. We want to, normally, we want to skip that outbox, right? So that'll look something like this. Normally, we'll skip the outbox. And then this is a little bit of a trick. If it is 0, then we actually want to skip that jump so that we don't do this jump here if it's 0. So we skip it. So we'll see what this looks like. We have a 7, we throw it in the trash, right? Because we skip the jump if 0 at instruction number 2, then we jump, and then that just jumps us back to the top of the file. So only the zeros go through. Let's speed this up. So let's see how this ranks for efficiency. 5. Good. Speed challenge. Oh no. Yes. We can do better. So I'm not necessarily going to do all the optimization challenges, but I think there's a good lesson here, which is when you see something like this, when you see a jump that just leads to another jump, there's always a question of can you do better? And the answer is yes, because keep in mind, each jump is an instruction. So if we have something that's not a 0, right, if we have a 7 or a 9 or an A, we jump here only to immediately jump here, which means that what we can do instead is this. We go straight back to the inbox, right? So if it's a 0, it still goes to the same path. We have the inbox, then we jump to here, we go to the outbox, and then we jump to the beginning. But if it's not a 0, we've actually eliminated a step, right? We've gone inbox, we skip this because it's not a 0, and then we just jump to the top instead of having to jump twice, right? So for everything that's not a 0, we've eliminated a step. So let's see if this still works, and then let's see if we have any... It should be more efficient, and we'll see if we've actually met the target for that. I'm excited. Close. Okay. I'll come back to this one, but that's an example of how you can economize these kinds of things. Yeah, we'll take a look. I might not do all the optional ones. I might want to come back on another day and do those for fun. But I think these ones are still, pretty routine tasks. Yes. So that's what the green buttons are for next to each level. We'll take a look at that once we're done with this. So for each thing in the inbox, multiply it by 8 and put the result in the add box. Can you do it using only 3 add commands? Okay. Well, as a seasoned computer scientist, the thing that jumps out to me here is that 8 is 2 to the power 3. So I think what we can do here, in order to multiply by 8, instead of adding it to itself 8 times, is we'll actually multiply it by 2 3 times, and that's the same thing as multiplying by 8. So we'll copy, store it in a tile, we'll add to itself, and in the previous one, when we just needed to multiply by 3, we immediately did another add, right? But actually what we're going to do is, each time we do an add, we're going to store the result of that computation. And we need to do this 1, 2, 3 times, and then outbox that. And let's see what that looks like. So we'll take 6, makes 12, and then store that. Right. Exactly like that. And that gives us 6 times 8, which is 48. Yep, and then I just forgot to make this happen every time. So we'll do a jump. So it's going to be a little bit silly for 0. We'll look at 0 now. So this is going to look super silly. Yeah, 0, makes 0, and then times 4 is 0, and then times 8 still 0. So I don't know if it's going to say this is the most efficient solution, but because obviously we could have jumped just to the very end if it was 0. So let's see what it says. Oh no. That's interesting. Oh, there's no jump if 0, there's just a jump. That's why. Okay, so we actually couldn't have made that any better. Alright. So, great. We got both little green bubbles for number 10. So, let's take a look at number 11. Subtraction? Ah, great. So we have a sub-command now. That's exciting. Alright. So it says, first subtract the first from the second in the outbox, and then subtract the second from the first and put in the outbox and repeat. And we have a new command called sub, which subtracts the contents of a tile from whatever value you're currently holding. Yeah, I appreciate that they put from in all caps, because that's going to... I'm probably going to get that backwards at least once. So the first thing that jumps out at me about this is because we know that when we do a subtraction, or an addition for that matter, we lose the value we're currently holding. So because we need to subtract the first from the second and then the second from the first, I think the first thing we're going to have to do is save both values, right? Because we couldn't just do this and immediately start subtracting like that, because then we'd lose that second value, and then we wouldn't be able to do the subtraction in the opposite direction. So I think we need to start, and this time we'll store it here, right? So we'll sub 0, is that right? So we subtract the first from the second, and then the second from the first. So after we do this inbox, we'll have the second value, and then subtract the first from the second. Yeah, so this is the correct direction, right? So we'll do that and then outbox that value. And then we will copy, nope, not copy 2, copy from 0, subtract 1, being the second value, and outbox that. And I'm not going to forget this time, we're going to jump all the way to the end. So, okay, let's just make sure that's right. So we have 4 and 6. I'm going to speed up each step a little. Okay, so the first thing we want to do is subtract the first from the second, so that should be subtract 6 minus 4. Good, 2. Okay, alright, so this is correct then. And then we should do 4 minus 6 and get minus 2. Perfect, alright. Let's play this through to the end. 8 and minus 8. This is silly. 0 and 0. 15 and minus 15. Yes, any math nerds will have picked up on the fact that these two numbers were going to be additive inverses of each other, because that's a fact about math. Great. I don't have to come back to this. I'm gonna skip 12 for, well, no, let's do it. Let's do it. Okay, so for each thing in the inbox, multiply it by 40. So your first thought here might be, well, 40 is not a power of 2, because they go, what, 1, 2, 4, 8, 16, 32, 64. They skip right by 40. The thing that occurs to me about 40 is that it's 8 plus 32. So it's 2 to the third power plus 2 to the fifth power. So I think we can do the same thing as before. We just need to kind of store an intermediate value. So let's start the same way we did, right? So we start by copying it down, adding it to itself, and copying that down, and we need to do that 3 times. So then we should have whatever thing times 8, right? We should have that. So 1, so this should be 8. 2, no, I need to do it one more time. I'm not good at counting. Add. Probably 2. And that gets us 8, right? And then let's also copy that number here. So that gets us 8. We'll do it one more time, which gets us 16. 0, one more time, and that gets us 32. And then we can add, we've got 32 here, we've stored the 8 here. So we'll add those two together and we'll outbox that. And let's make sure that's right. So 6, so we should get 48 in the first box. Or no, it's going to store it in the second box. 48, good. And now 96, and now 192 plus 48 makes 240. Not enough stuff yet, because again, I forgot to jump all the way. So let's great. Oh, and again, this is going to look super silly, because 0, yeah, it's a lot of zeros right there. Alright, let's see how we did. Ah, okay. Well, actually, let's see what we could do. If anyone has any suggestions, feel free to chime in. I think... Oh, we don't need to do this copy to. Yeah, we don't need to do this, because we're already holding the value. There's no reason to write it down. We're holding it, right? So we can get rid of that. Let's see if that does it. It's kind of cool when it goes at high speed like that. I like the sound. So let's see if this was efficient enough. Still not. Still not. And how about speed? Okay. Okay. Well, I noticed that 56 is 4 times 14, and 60 is 4 times 15. So I think I have an extra command. I don't know what it is. I'll come back to this another time, I think. But let's look at the next challenge. I think it'd be fun down the line. I don't know that I'm going to get through all the challenges tonight necessarily, but I think it'd be fun to come back another day and maybe just try and make some of them more efficient, and the challenges get harder, we'll see. And, you know, they're quite hard to optimize. How can we know? Okay. Ah, we have comments. Hello world, classic. I'm gonna get rid of that for now. Okay, so get 2 things from the inbox. If they're equal, put one of them in the outbox, and if they're not equal, then we can throw them in the trash. So obviously we need to start by saving the first value. And then, because we can just put one of them in the outbox and do nothing otherwise, we don't need to save the second value. What we need to do is compare it. So this is an old programmer's trick, right? It turns out modern assembly language does have a thing for saying if 2 numbers are equal. But when it didn't used to, this is an old programmer's trick, is the way to tell if 2 numbers are equal is to subtract them and then see if you get 0, right? So if we don't get 0, then we could just go back to the beginning of the program, right? If we do, then we want to outbox, right? We want to outbox one of them, which means we need to copy it, because right now we'd be holding 0. So copy from... See, this is where it can get confusing sometimes, is that when I say that we have 0, I mean that we're holding the number 0, but then we say copy from 0, but that's the space number 0. So this can be a little confusing, and obviously in this case we need to jump. So let's try this. So we have 4 and 9, obviously not... Oh no. Oh yes, I wrote copy from, I meant copy to. Whoops. Alright, so 9 and 1, obviously not equal, so we'll take 9, we'll subtract, we'll get -8, and then that's not right, so we just throw it in the trash, we start over again. So 1 and 1, this time we'll subtract them, and because they're equal, we get 0, which means we take the 1, and put it in the outbox. There we go. So only 2 of those pairs were equal, so only 2 things got put into the outbox. Let's see how we did. Good. Good for size. And probably... Oh no, actually not good for speed. I'm going to come back to that one. I'm going to come back to that. Maximization. The big numbers only. Okay. Oh, and we have a new command, jump if negative, which jumps only if the thing you're holding is negative, less than 0, otherwise it continues to the next one. Right? So because we're going to start the same way, right? We're gonna copy things down, but because we could be setting either number, obviously we have to copy both numbers down. We have to start with that. We have to store them before we do any kind of operations on them, because once we start doing operations, we lose the values. Okay, so we're holding 1. We're going to sub 0, right? So we're going to subtract the value in 0 from the value in 1. And then if it's negative... So if we take the value in 1 minus the value in 0, and that's negative, that would be like 1 minus 2, right? So it means that the value in 0 is bigger. So if it's negative, then we want to copy from 0 and outbox. And if it's not negative, so this is how I'll jump around it, right, is like that. If it's not negative, then we want to copy from 1 and outbox. And I'm actually gonna get rid of this, and I'm gonna replace it with this, so we'll jump straight to the outbox. So as we work with more complicated algorithms like this, the jumping is gonna get kind of complicated, and I might go a little fast. So feel free to yell at me to break it down. Oh, hello Tabitha, and hello haha12btw. Tabitha, by the way, is the person who introduced me to this game, so I don't. I think she's in class right now. I'm not sure if she's actually listening. But I'll say hi in the chat. Okay, so let's see if I got all of my jumping correctly. So 7 and 3. Minus 4. Oh, you are listening, because you said you're not in class. Okay. So the bigger one here is -1, confusing. Okay, so I guess I did get all of my jumping correct. No, Twitch Prime, it doesn't mean I'm paying to stream. I am a paid subscriber to another channel, I think is why it says that. No, the streaming itself is free. Alright, so some optimization that I could still be doing. Alrighty. So this would be a fun one, I think, to come back to, and oh, okay, I see. Thank you. Yes, that's right. That's how I got that. I got a free subscription to the first person I subscribed to by linking Prime. Yeah, that's it. All right, so this is one I'm going to want to come back to and optimize, but let's move on for now. Going to let you enjoy this awesome cutscene.
And that, ladies, is how I saved a bundle on my long-distance telephone service. Back to work, everyone.
A massive army of machines has surrounded the city. The machines are not moving, and they are not communicating. Local authorities are investigating.
Can I get the dog to say hello? I can try. She's in the other room. I'll try to get her in here. So this is great. The two people who are watching is someone who already knows how to code and the person who showed me this game and already finished it. Well, welcome. Let's keep going. Each thing from the inbox to the outbox, but if a number is negative, first remove its negative sign. Okay, well, let's, well, first what we can say is that if something is not negative, right, then we can immediately just outbox it. So we'll start with that, right? So that's going to be like that, right? So if it's negative, we'll jump past this, but if it's not negative, then we'll outbox and then just jump back to the beginning. Yeah, it's I like it a lot. I definitely recommend trying it. So don't watch for too long because I'm probably going to spoil some of the harder ones. It's been a while since I played this, but I still kind of remember my solutions to a few of them. So okay, to remove the negative sign, I think the easiest thing to do, so like let's say we have -9, is we'll subtract it twice, right? Because -9 minus -9, that's 0. And then subtract -9 again, that's 9, right? So we'll subtract it twice. So okay, if it is negative, we need to remember it, right? And then we'll subtract it and copy that down. And then we'll subtract that and copy that down. No, we don't need to copy it down. We can just outbox it. I think that's right. Let's try it. So 9, that's pretty... Alright, let's make sure that works though. So now we should just outbox it. Yeah, good. And we jump to the top. Okay, so -9. Oh, whoops. Did I say... I said copy from... Yeah, I said copy to. Copy to 0. Alright. Yes, I'll get the dog once I'm done with this level. Let's see. 3. Alright, so now what we should do subtract it to get 0. Save that, and then subtract it to... Oh, no! I'm so dumb. Okay, we don't want to copy it down. We just want to subtract twice. See, I was being too clever. 2. Okay, good. Alright. Awesome. Alright, let me go get the dog. Okay, the dog will have to visit in a couple of levels because I went to go get her and then she asked to go outside right at the same time. So she'll come in a few minutes and then she'll say hi. Alright. Let's see what this is. The ones on the left branch are the harder levels. I might want to go back and do those later. Okay. So send a 0 to the outbox if they have the same sign. Send a 1 to the outbox if their signs are different. Repeat until the inbox is empty. Okay. The key to this one, I'm going to say, is that they give us a 0 and a 1 on the carpet already. And what's this? Oh, that's comments. Okay. So I think... Because we're sending a 0 or a 1 and not the actual numbers themselves, I think we don't need to copy them down. But what we will do is, based on whether they're negative or not, we'll remember their sign with a 0 or a 1. So let's say that if it's a positive number, that's 0, and if it's a negative number, that's 1. Then what we'll do... Let's start with if it's negative. Then if it's negative, then we'll remember a 0, right? So we'll copy, or a 1, sorry, it's negative. And so 0 is going to contain the sign, effectively, of the first number, right? And if it's not negative, then we want to copy from 4. Right. I think like that. Let's try that. Okay, so we have a -2. So that we should be copying a 1. So we throw the number out entirely, we just copy the 1, and we put that in the first slot. Okay, good, that seems to work. And then we'll do the same thing again. Same exact thing, but this time, so I'll set up the same structure. Do that, and that. 5. Jump. And copy 4. But this time we're going to copy to 1. 1 is the place that's going to hold. Okay, bye Tabitha. Thanks for watching. So 1 is the place that's going to hold the sign of the second number. So let's make sure I got that right. I have a sneaking suspicion I didn't, but let's see. Yeah, I didn't. How did I manage to copy the numbers on themselves? Did I do a copy 2 instead of... jump. Oh yeah, I just jumped right to the... I didn't do that right. I'm going to do the other way. So if it's negative, oh yeah, I did that, then I wasn't thinking about this. Right, the jump goes here. So it'll be jump to there. Alright. Let's make sure I have that right. So, no, okay. Alright, well I have to go let the dog in, be back, and then we'll figure out what I did wrong. Okay. Back to work. Alright, what did I get wrong? I did jump. Okay, let's just read it. So, if it's negative, then... Oh, yeah. Yeah, okay, I screwed this all kinds of up. If it's negative, then we want to copy from 5 and copy that to 1. If it's not negative, then we want to copy from 4. Okay, right. So this is how the structure can get a little weird when like you have to express it as a jump that jumps around a jump in order to express what to do when this condition is false, right? So like if it's positive, what to do. So let's see if that works. So 6 and 6, we should get 2 zeros. No, see, what did I do? Did I do the same thing up here? So it's positive, then yeah, I did. I want to do that. Yeah. See? I'm not paying attention. Alright, so this should be a 1 in spot 0. And then a 1 is positive, so it should be a 0 in spot 1. Good. Okay. So that gives us two numbers that express the sign. The 0 and 1 express the sign. And then what we care about from the description is if they have the same sign or if they have different signs. And we know that if we want to compare two numbers, we can subtract them. Right? So we've just finished copying to 1. So now we can subtract 0. And then if we get a 0, that means they have the same sign, right? So if they have the same sign, then we want to send a 0 to the outbox, and we know that there's a 0 at spot number 4. So if it's 0, then we want to copy from 0, or 4, excuse me. Copy from spot 4, which has a 0. That squeaking is a dog playing with the toy. And then if it is not 0, then we want to copy from the 1. We want to send the 1. And either way, we want to outbox, which means I need another jump to jump from here to going to the outbox. And I'm not going to forget this time. We also need to do this multiple times. Jump all the way up to the top. Okay, so minus 9, that should be a 1. Yep, good. And then a minus 3, that should be a 1. Good. And now, those are the same sign. Great. It looks a little silly to be doing 1 minus 0 and then outboxing a 1 that even though you're already carrying a 1, but you could get minus 1 there. But it occurs to me that in the case where they're the same sign, you're already holding a 0, so you could just outbox that 0. So this definitely is not the most efficient solution. Let's see what it says. How loud is that squeaking? A little loud. Okay. Wow, that is the worst I had ever done on one of these. So I'm not going to spend too much time optimizing this, but I'm just curious if we remove the thing I was talking about. If it's a 0, then we can just outbox that 0 and not bother with copying or this jump. Right. So that actually eliminates a lot of steps, come to think of it. Let's see if that's more efficient. Okay, so the algorithm's correct. And now it's, I wonder if, hopefully it's not more than double the number of steps. Right. 28, 58. Okay, still more than double. Okay. Yeah, that's definitely one that it'll be fun to come back and optimize a little bit later. So let's... hello. Dog's causing a ruckus. Alrighty. And I'm gonna let everyone enjoy this cutscene. Alright, let's continue on our merry way. Countdown. I presume this isn't the show Countdown. We're not going to be trying to get to numbers with other numbers. I love what you've done with your hair. For each number in the inbox, send that number to the outbox, followed by all the numbers down or up to 0. I used to. So in my last year of undergrad, I was watching Ricky. He goes by the Rixer, because it was just kind of a fun thing to do on the weekends. And I noticed, I just picked up on little things like having the Be Right Back image and how to fade stuff. I also got a lot of help just last night from my friend Josh, who also started streaming. I'm going to give you his handle. So he helped me a little bit setting up the software to do this. But mostly I was just playing with it this morning before work to see how everything balanced. And it's just kind of fun to do. Okay, so we need to do all the numbers down to or up to 0. And we have new commands called bump plus and bump minus that add 1 or subtract 1. Item on the floor, and the result is given back to you and written right back to the floor. Okay, right. So I noticed that we have positive and negative numbers and 0, so this should be fun. This is the first serious level, I think. Things are getting real. Okay. So obviously we need to start by remembering the number. And then I'm just going to start by assuming the number's positive, right? So in general, what we want to do is we want to start by outboxing the number, and then we want to bump it down, and then we want to outbox that, and then and if we get 0, then we're done, so we can go back to the top. So let's make sure we got that. So 5. I'm going to do it step by step because it'll be faster. 4, 3, 2, 1, 0. Oh, whoops. I think I'm supposed to do all the way 20? Yeah, okay. So then this should be... I can't just reverse that though, can I? Because once we outbox a number, we're not holding it anymore, so then we can't see if it's 0. So I think instead of that, I'm going to do... what do I want to do this? I think... we'll do the jump here, and then we'll just make this a special case. We'll say then outbox and jump to the top. Not very... There's got to be a better way to organize this. But okay, let's see if that works. It's only going to work for positive numbers, but 6, 5, 4, 3, 2, 1, 0. Right. Right. Okay, so now we need to think about negative numbers. So that we're going to have to determine right here. Oh wait, no, right, well, yes, right here. If it's negative, then we want to... This is going to get ugly. If it's negative, then we want to outbox it and then bump it up. So we're essentially replicating what we had before, yeah. And then if it's 0, then we can do this. Otherwise, we will outbox and we will jump to do this again. Does that work? Alright, so 6, 5, 4, 3, 2, 1, 0. Minus 2, minus 1, 0. Ah, okay. So that worked for negative numbers, but now we need to deal with it being 0. Okay. Well, well, that's easy. So if it's 0, right? If we can just right after we inbox it, we don't have to save it. Then we can just jump right to the outbox. So let's see if that works with 0. Minus 1, 0, 0. Yeah. So that 0, it's hard to tell at this speed. That 0 doesn't even get saved. It just immediately gets outboxed. That's a nice trick. Okay. Well, this is going to be... Yeah. Well. Okay. So I think this is a good example of when it says... You can see it says in little gray text right there, which is pretty low contrast. In many cases, it's not possible to optimize both with one solution. So I think this is probably one of those cases that you can do it in fewer commands, but it might take more steps. Well, let's keep going. Actually, I'm curious how we're doing for efficiency on the ones before they introduced the concept. Oh, okay. I'm curious. I wonder... So I think the bottom bubble is the number of steps. So this new ability. This is... Okay, so what's going on here, right? The point of this level was to be clever, right? Or not clever, but to use the jump tool and to be able to write this in just 3 commands. But of course, we can do what we did in the very, very, very first level and just write this a bunch of times. And I'm actually going to write it from the top down, not from the top up, not from the bottom down. So if we just write this like 1,000,000 times, we could write this literally 1,000,000 times, remember, and that will be fine, because as soon as we get to an inbox command and there's nothing to do, that's the other way the program can terminate. We don't necessarily have to reach the end of the instructions. So let's just see if that works. Nope, I need to write it one more time. Just one more. Great. So obviously, we're going to fail the size challenge. We have 8 times the number of commands. But I bet you, yep, we actually beat the speed challenge. We didn't just hit it, we beat the target. This reminds me and this is a classic thing in programming. This reminds me of the story of one of the first PostScript printers that Apple was developing. They wanted to show it off, like they used to do with the iPhones. They booked these giant convention centers, and they were unveiling their new PostScript printer. And they wanted to print a particular document, which was this complicated immigration form or something like that. And they, I think this was actually, something that Steve Jobs was working on. And they went to show it off, and he was mortified because, they clicked the print button or whatever on their computer, and it took 2 minutes of translating, it took 2 minutes of unraveling that PostScript document into a set of instructions that the printer could actually execute. So it just sat there for 2 minutes. And the way they actually managed to quote-unquote optimize it was by unraveling all of their loops. So this is a great example. They got rid of the size optimization in favor of the speed optimization, because no one who was going to be sitting in this convention center was actually going to be looking at their code that they were passing. This hugely long document that could have been expressed so much more simply, but it made it fast. And I appreciate that this game is teaching people that lesson. And I think that's why it says, it's impossible to do both at one time. So, great. But you notice it ticked off both bubbles, so you don't have to solve them at the same time just to get them. You just have to solve each of them. Okay. So, we have labels now, so we can give our squares names. Awesome. It's like we have variables. Secret. Okay, so for each 2 things in the inbox, multiply them and outbox the result, and don't worry about negative numbers. We have labels. Okay. Well, I appreciate these labels, but I think I'm going to trash them. But that's a 0. That's definitely a 0. I didn't write that. That was there. So I don't know why this code is here. Could be a hand. I'm going to get rid of it. Because I think what we can do, I don't think we need that 0 at all, right? Because multiplication is just successive addition, right? So when you have 4 times 2, that's our first pair. That just means, add 2 to itself 4 times, or add 4 to itself twice. So I think what we can do is we'll copy the first one down, right? And we'll copy the second one down. You see, I did it again. I said copy from instead of copy to. Right. And then we'll keep track. So let's call this our sum. This is the funny thing about this game, is that you have to handwrite these labels. So it's just kind of a funny... They look terrible because you have to write them with a mouse in my case. But I'll do my best. My mouse hand is also not my writing hand, so these aren't going to be good. That's not terrible. So we want to... So we have our sum and we have our count, right? So that count is basically telling us how many times do we have to add the sum to itself, right? So what that means is that we'll copy from our sum, we'll add the sum, and we'll copy that back to the sum, right? So we're adding it to itself. And then we'll say, okay, we've done it one more time. So because that's the count of how many times we have to do it, then we reduce that by 1, because we've done it one time, we have to do it one fewer time. And then we'll do that. And then once it says, once we bump it down and it says, okay, you have to do this 0 more times now, then that's our sum, that's our final sum. So we'll outbox that. Let's see if that works, and I'm not going to forget. All right. So we have 4 times 2. So 4 will be our sum, and 2 will be our count. So this should be 8. Oh no. Oh no, I'm doing all the wrong numbers. Look at that. Oh man. Okay, I screwed this up. Okay. Yes, I see why the 0 is necessary, but let's come back to the fact that I used the wrong... Let's start with the fact that I used the wrong numbers. So copy from sum, add a sum dot count. Yeah, the problem is that I was jumping right after bumping. So I need to start with copy from sum, I think. So let's see if that fixes the problem of us using the wrong numbers. So 3 times 4. Okay. So 3, yeah, makes 6. 6. Yeah, you see. What I'm doing now, yeah, good. Yeah, now I'm just doubling. So this is not right at all. 3 times 4 is not 48. Okay. Well, there goes that plan. Let's start again. Let's start again. Okay, I see why the 0 is necessary. So, right, the first thing that we're going to do is we are going to make that 0 our sum, right? And we are going to make the first thing our count. So, that'll be our count. And then we also need to store what the number is, what the other number is. We need to store that, because what I was doing before was the multiplying by 2 thing, right? But you need to store the original number that you want to actually multiply. So then we'll take the next number and we'll put that there, right, for our multiplicand. Okay, good. I'm happy with this. Okay. So then, here's our loop. Our loop is going to look like this. It's going to be, we bump the countdown, right? And that'll be our, if it's 0, then we're done, right? But we'll come back to that. So then, we bump the countdown. We're going to take our multiplicand. We're going to add to the sum, and we're going to copy that to the sum. And then, once we're done, then we're going to copy from the sum, and we're going to outbox. And I'm not going to be so bold as to just play it. I'm going to go step by step to make sure that I'm right. So 0 is our sum, 3 is our count, and 5 is our multiple. Okay, so we start, 2. So we have to do it, this is us saying we have to do it 2 more times, right? 5. So we have to do it 1 more time after this loop, that's 10. Yeah, you see, I've done it in the wrong order. So we will do that. Okay. Alright, so we're going to do 7 times 5. Alright. So 5, we have to do it 6 more times. Now it should be 10, we'll do it 5 more times. Okay, I feel pretty good about this. So that should be 35 for the outbox. Yes, aha, see, I said I wouldn't do it again, and I've done it again. I've forgotten the outer loop here. Alright, so 3 times 4, hopefully we'll get 12. 2 times 6, that's 12 again. 7 times 0. I don't feel good about this. Oh no, that was fun. That was fun. That 0 made me nervous. Yeah. You see, so that's not good. So it says don't worry about negative numbers. How did I end up with a negative? Oh, it's because one of them was 0. One of them was 0. Right. So if at any point we get a 0, then we can just outbox a 0, right? So let's say that we made another little thing, another little routine down here where we outbox a 0. And now what we can say, that's not what I meant. Now what we can say is if at any point right after we inbox we see a 0, then we can short circuit this entire thing and then just send a 0 through. Because anything times 0 is 0, we know that. Right? So if at any point we see a 0, then we'll just send a 0 through and not bother with doing any actual multiplication. 5 times 7 is 235 of them. Yep. See, yeah, and you can see, we see a 0, we immediately send a 0 through. Ah, what did I do? Did I not skip back far enough? That was odd. That was 6 times 6. What happened? Something about this. Was I too clever? No, that seems fine. That was weird. What happened? 6 times 4. Tabitha, you put that in my Twitch chat. I saw your Facebook message. I was just going to finish this level before replying to it. Created a system for maintaining training files and records that is able to withstand continuing department growth. Oh, you can't hear me. Okay, fine. For those of you who are listening, I apologize for the loud typing. Okay, so we still have a problem. 36, but we outboxed 72. So I wonder maybe if something didn't get reset properly. I didn't even see what the number was when that happened. So I need to let's go a little bit more slowly. Okay, so the sum is 0. We're doing 6 times 3. Nope. $18. 6 times 6. Zero times 6 is 0. Oh wait, why is there only one number left? I didn't short circuit correctly, did I? Oh yeah, it's because right, you can't do this. If you have a 0, you've only inboxed one number. So you can't immediately go and right. So if the first number is 0, you have to first inbox the second number, take the second number from the inbox in order to just throw it in the trash and then copy from. Okay, so this should work. So we're gonna look for a pair where the first number is 0. I don't think we're gonna get. No, we are. We're gonna get 0 and 2. So we should see, yeah, good. It takes both of them, and this is going to be 6. Okay, good. All right, so that was it. That's actually not terrible. So this actually should be a pretty challenging one to come back and optimize later. 21 commands, kind of a lot. Yeah, so you can see this is the last branch. Oh no, there's another branch. Well, this is the blue branch, but already we're talking about things like Fibonacci and modular arithmetic, and getting into scary territory. Let's press on with the main branch. Do you know what a zero-terminated string is? Alrighty, cool. See you later, Zach. Thanks for joining. inbox is filled with 0 terminated strings. Add together all the numbers in each string, and then when you have a 0, put the sum in the outbox. Okay. So we'll start the same way as the other one, right? We'll have our sum. Excuse me while I try and write letters with my non-dominant hand. Okay. So we'll start the same way where we take our 0. Let's remember that this is a 0. So 0. And we'll put that in our sum. Then here's what our loop is going to look like. So we're going to inbox, and we're going to add that to the sum. And then the way we're going to get out of that loop is if we have a 0. So if we inbox and it's a 0, then we're going to copy from our rolling sum, we're going to outbox, and I'm not going to forget this time. I'm going to jump all the way to the beginning. So let's see what that looks like. So we start with 0. 7 we add, and then throw it. Oh no, I didn't. No, I'm such an idiot. I added it, I didn't copy. Alright, copy to the side. Try that again. Makes 11. Outbox. And when we initialize to 0. 12. Good. So the 0, yep, we see a 0, we just immediately are done. Great. That was a pretty easy one. Given how easy this level was, I suspect that it's leading up to doing something more complicated with the idea of 0 termination. But even that, you know, a relatively simple level like that, there's some room for optimization, which is nice. There's a GitHub repository, by the way, out there of people who have really optimized these. Like, I think there's some of them where they haven't managed to beat the targets, but the majority they have, and it's pretty serious. The smallest numbers only. Okay, so for each 0 terminated string, send to the outbox only the smallest number you've seen in the string, and you'll never be given an empty string. Okay. So I think the way this is going to work is, obviously we need to store, as we're going along, the smallest number. I'm just going to make that a less than sign, because I don't feel like writing the word smallest. But also, you know, finding whether one number is smaller than another is going to involve subtraction. And we know that when we do subtraction, we lose the, you know, whatever number, we lose both numbers. We lose both the, what are they called? The subtrahend and I forget. Anyway, so we also need to store the current number that we're processing right now to determine whether it's the smallest number we've seen so far. So each string, the first number that we see is going to be our smallest number. So we're going to say immediately, it's the current number. It's also the smallest number. So we'll start with that. That's how we'll start each string, right? So I'm going to put the big jump so that I don't forget at the end. And then what we're going to do is we'll take the next number and we'll say, okay, this is the current number. And then we will subtract what do we need to do? Well, I was thinking at first we would subtract the smallest number. But actually, we want to do it the other way, right? Because we have a jump if negative. We don't have jump if positive. And we're only going to get a negative number. Oh no, I'm sorry. This is right. Because let's say, you know, we're going to get 3 and 12 and 2 in our first set. So 3 is going to be the smallest number. When we get that 2 and say it's the current number, and then we subtract the smallest number, that's 2 minus 3. That's a negative number, right? So that means that when we subtract this number, if it's negative, then it's the new smallest number. Otherwise it's not. So we'll start over again if it's not. But if it's negative, then we want to copy the current number and say that it's the new smallest number, and then start over again. So let's try that. 3 is the current number, and it's also the smallest number. That's our initialization. Then we say 12 is the current number. That's positive, so we know 12 isn't smaller than 3. That's negative, so we know that it is, so we say it's the smallest number. Ah, you see, I forgot. When we inbox, if we get a 0, then we have to actually report our findings. So we copy from the smallest number and the outbox. Right. Let's try that again. So 4 is the current number and the smallest number. 10, positive, so it's not smaller. 1 is the current number, and that's negative, so it is smaller. So we put that in the current smallest number. We see a 0, and so we immediately jump to copying from the smallest number, putting it in the outbox. Okay, I'm happy with that. That's probably correct. So the smallest number here is 52. Great. So obviously some optimization yet to do here. Just going to take a second to plug in my phone because it's about to die. Okay, so now we have a cumulative countdown. The volume beneath staircases. So for any math nerds out there, that is a calculus joke. Okay. So the sum of itself plus all the numbers down to 0. For example, if inbox is 3, outbox should be 6, because 3 plus 2 plus 1 is 6. So it doesn't say I don't have to worry about negative numbers, but it does say numbers down to 0, which I'm going to take to mean that I don't have to worry about negative numbers. Okay, obviously we're going to need to store our sum as we go. And then each number that we take is kind of going to be our count of how many numbers we have left to add. So I'm going to try and write the word count. So we'll start by taking our number and putting that in our count, and then that helpful 0, which we may as well label just so we don't get confused, 0. So we'll take that 0 and we'll copy it to our sum. Okay, so that's our initialization process, and then in order to sum up the find the area under our staircase, right? We'll start by bumping down the count. No, we don't want to start with that, do we? We don't want to start with that because then we'll be adding one less. So maybe, I'm not sure we need the 0. It's probably going to turn out that we do, but let's see. So we copy that to the sum, we bump down the count, and we add that to the sum. Because we know that when it mentioned first, initially when we bump, then not only does it bump down that number, but we're holding it. It's kind of a twofer. You're making an operation on your memory, but also in your register, right, in the thing that you're holding. It makes that change there too. So it's kind of a cheat. I appreciate that about it. It's very efficient. So then we add that to the sum, and that's going to be, we're going to keep doing that until the count is, I think, 0. And then at that point we'll copy from the sum, we'll outbox, and start the whole thing over again. So let's see if that's right. So 3 is our count and our sum, so we're going to bump it down. Yeah, see, I did it again. I added, but I didn't store. So 3, like it says in the introduction, this should be 6. So plus 2 is 5. And plus 1 is 6. That's 0. So then we... Yeah, I'm happy with that. Now, I see a 0 on the conveyor belt. It's making me a little bit nervous. Yeah, you know what's going to happen here, don't you? Yeah, it's negative. So we could fix this just by saying jump if negative. Right, like that. We'll see if that works. Because we know the only way... If we get past this jump of 0, the only way it was negative is if it was 0 to begin with. So it's a cheap trick. We could probably find a way to be more efficient about it. But like I said, I think what might be fun is to kind of go through just my first thoughts on some of the levels today, and then, you know, next time, whenever that is, hopefully soon, then we'll come back and try to economize some of these. But it turns out this does actually meet the side challenge, so even though it was just my first attempt, I guess it wasn't that bad. So let's keep going. Let's see what's next. Ah, cutscene. Righty. Well, I will once again turn up the volume and let you enjoy it. Spooky. I kind of like that about this game, you know, from an artistic standpoint, that there's this kind of subtext of, you know, humans acting like machines, and are the machines taking over? That I appreciate. Big changes are coming. Oh, indirectly. Okay. What does that mean? You will see. It's going to change everything. So imagine each thing in the inbox is an address. And each address refers to a tile 0 through 9 on the floor. Your task, for each address in the inbox, pick up that letter at the address and outbox it. You can access tiles on the floor indirectly. Observe this example to see how it works compared to what you've been doing so far. So we can see that there's a copy from 12, which will copy from the space numbered 12, right? Which is just, that's the number 8. And then there's copy from brackets 12. We'll see what that does. This will just give us 8. Yeah, you see that arrow? It copied from bracket the space 12, which means look at the number in space 12. That's 8. And then you saw that green arrow point to space 8. So this is called, by the way, a pointer in official computer science terminology. When you have some value that isn't significant as a number, it's significant insofar as it points to somewhere in your memory. That's called a pointer. For reasons that I think are probably obvious now that I explained it that way. So, okay, let's throw this out. So your task is to pick up each letter in the inbox, and then pick up the letter at that address and outbox it. Okay, so let's call this space, since it was the one they were using, let's call that our address. So we'll take each thing in the inbox, we will copy it to our address, and then we will copy from, and you can see this slider here lets us pick between whether we want direct or indirect references. And here we want to copy from the memory location referenced by this pointer, this address, and then we want to outbox that. And we will do this until there's nothing left in the inbox. So we haven't had one of these in a while, a program that is short and terminates when there's a thing in the inbox. K-A-Y-R-L. Oh, I was thinking it might be an actual word, but it's not. Oh well. So you should notice, by the way, a thing we can't do is pick up a number and then without storing it, use it as a pointer. And that's actually pretty accurate. That because of how computers work, you need to have a stored pointer in order to use it. You can't just have it in a register and then use it as a pointer because it's doing too many things at once. It's both remembering a number and then going and finding based on it, and that's sort of holding two numbers at once, even if one of them is just sort of in the head of our worker. This appears to be the most optimal solution. And I will be right back because apparently the dog wants to go out again. Whew, alrighty then. Honestly, having to take the dog out twice in 2 hours is doing pretty good. Could be a lot worse. String storage. And forbidden. Each thing in the inbox is an address of a tile on the floor. For each address provided in the inbox, outbox the requested item from the floor and all following items on the floor. until you reach a 0. And then repeat. So, okay, so it seems like we want to, in general, do this. It's almost the same thing as before, except we just want to discard zeros because it means that it's the end of a word. So let's try that. So I noticed they've left this 24th spot blank, or 23rd spot, excuse me, numbered 24, 25th spot, number 24. And so we'll use that. So we'll copy from the inbox to our address. And then we'll copy from the point to by our address, and then we'll outbox, and we will do this unless we see a 0, and then we'll just go straight to the inbox. I think that's what they want, right? So for T, I know we're not supposed to read the words, but I'm gonna read the words. H. How did you expect H? You gave me a 7. Or no, you gave me a 15. I don't understand. Oh, all following items on the floor until you reach a 0. I see. Okay. Okay. So what they want then... I see. Copy from address, and then we should bump the address itself. So increment the address itself. I see. Okay. So here's what we'll do. We'll do this. And then if we bump it and we see a 0, then we'll go to the beginning. Alright, I think that's what they want. So 4 gives us that T. So we outbox that. And then, now it's 5, right? That's an H. And we'll try it again, it's 6. So we'll copy it, and that's a 0. So we're done. Yeah, I see. So let's see what this says. The target XXX is awake. XX. Take this. X. Okay. Interesting. The target is awake. Take this. I appreciate that they kind of encoded a message in. Oh, look! We nailed it. Awesome. String reverse. Hola! Oh wow, it's even the whole sentence backwards. See, that only works as a visual gag. It wouldn't work as a spoken gag. For each 0 terminating string in the inbox, reverse it and put the result in the outbox. And they've given us a 0. Okay. Well, let's start with just recording each string, right? So we'll start by taking in the inbox and copying it to the place pointed to by this. So again, this is going to be our address. It's going to tell us where we're going. And then we want to bump the address. So here's what we're doing. It's going to be 0 to start with. So we're going to take the first thing and copy it to the place signified by 0. And then we're going to bump the address, right? So let's see what this looks like. Stuff. Oh, yeah, I'm so dumb. All right. And then until we see a 0, right? So that'll bring us to the next part of our program. You sure can. So H. And now this tells us the next letter is going to go in spot number 1. So it looks wasteful when we're dumping that number out, but remember, bump is the cheating operation. It does both things, so it's okay. It looks like we're throwing it out, but it's still being useful. Okay. And now, we're going to see 0. So now we can do the next part where we reverse it. So we start by bumping down our address. Then we copy from the place referenced by that address. And then we outbox that until the address is negative, I believe. Right? So once the address is negative, then we just want to bump it up so that it's 0. And then we can start over again. So let's see what that looks like. Speed it up a bit. So C, L, O, U, D, and there's a 0, so D, U, O, L, C, and that tells us we're done. Good, I'm happy with that. So it's interesting, because the inbox flows up and the outbox flows down, the words are actually, like if you read them from top to bottom, it looks like we're not doing anything, but if you think about it, we have to reverse it in order to be able to read the words from top to bottom both times. So not an optimal solution, but apparently it's pretty close on both fronts. That's interesting. Alright. Inventory report. For each thing in the inbox, send to the outbox the total number of matching tiles on the floor. That's very interesting. Okay. 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 So this is just a 0. I think we're going to leave this 0 where it is because it tells us that it's the end of the things we have to search through, right? But what we do need is a count. We need a count of how many things we've seen, right? So make this our count. And this is the letter that we're going to be checking against. All right. Great. So what we need to do is we need to start by we'll call this 0. I'm not going to take a lot of time to write that. So we'll start by initializing our count to 0, and we'll start by grabbing our letter and saying that this is the letter that we're comparing against, right? That's our initialization. And now what we're going to do is we also need to remember the address of the space that we're going to start looking in. Right, so we'll also put a 0 in there, so we'll copy that to the address. And what we'll start doing is we'll copy from the place referenced by the address, right? And then we'll subtract the letter we're comparing. Now, it seems weird to subtract letters, but I suspect this is going to work. I suspect that we'll be able to subtract letters and get some kind of numerical value. If I'm wrong, I guess we'll find out, and we'll have to think of maybe something else to do. So we'll subtract it, and then if it's 0, then we want to bump the count. And then go back to the beginning. Right? So we'll look all the way through, and then when we do this step and the thing that we see is a 0, that means we're done. So then we can copy from our count, and we can outbox it. And then we jump all the way back to the beginning to our initialization. So let's see what that looks like. First, we're going to say our count is 0, and the address we're going to start looking in is 0. And we're going to say x is the letter we're comparing against. So we're going to subtract, we get b minus x, which apparently is negative 22. Oh no, I forgot a step. Anyone see what it is? Anyone see what it is? We also, in the case where we just jump back, we also need to bump the address. No matter what, we need to bump the address. So, ooh, how do I want to do that? I want to, instead of jumping here, I'm going to jump past here, and I want to bump the address here. I think. Let's try that. Let's try that. So 0 is our count, 0 is our address, A is what we're comparing against. So A minus B, or B minus A, 1. So we don't increment the count, but we do increment the address. A minus A, that's 0. So we bump the count, and we bump the address. Good. Alright, so let's skip a little. Skip a bit, brother. So now, let's watch carefully. When we get to 14, that's a 0, so we should send the count through. Yes. Excellent. And we should set these both back to 0. Oh, I'm very happy with this. This should be correct. This should be correct. I don't know why the dog is barking. Oh, she's just trying to play with the cats. They don't want to play with her. Even at full speed, well, I'm not quite at full speed. Now, oh no, I am at full speed. Even at full speed, this one takes a while. So this is, this is an intensive process that's going through. Let's see how we did for efficiency. Nice. Probably not good for speed, huh? Yeah. Not that bad. Not that bad. But yeah, 393 steps. We're doing some serious computation. All right. So we got one cutscene. I think we're gonna do this cutscene, and then maybe look at one of the branch challenges, and then that'll be it for tonight. So I'll turn up the volume. I'll let you enjoy this cutscene.
Hey, where's Carol? Oh my god. This coffee is amazing. Back to work, ladies.
Breaking. Previous reports of Machine Army evaluate to false. Everything equals 100% fine. Whether within pleasant tolerance parameters or human skin layer, you're all going to be fine.
Anyone who watched Star Trek: The Next Generation will have flinched when that robot used a contraction, and you're all going to be fine. That's not right. All right, so I think we're going to end tonight. Instead of looking at the next challenge, which maybe we'll delve into next time, let's actually look at one of these optional challenges. See what we make of it. For each thing in the inbox, send to the outbox the full Fibonacci sequence up to but not exceeding that value. For example, if inbox is 10, outbox should be 112358. So the Fibonacci sequence, I'm sure many people know this, but for anyone who doesn't, is the sequence you get when you start with 1 and 1, and then to get every term in the sequence after that, you add the two numbers before it together. So 1 plus 1 is 2. Then to get the next term, you add 1 and 2, which gets you 3. Then 2 and 3 gets you 5. 3 and 5 gets you 8. And so on and so forth. To infinity. So they're giving us a value, and we want to send the Fibonacci sequence up to that value. Well, okay. So we need to remember, obviously, because the Fibonacci sequence requires adding 2 numbers together, we're going to need to remember them, and we're going to need to remember our value. So let's, I guess, start by constructing 1 and 1. So I think the way we'll do that, this is a 0. Z-E-R-O. I think the way we will do that is by copying from our 0 and copying that to A, bumping it to get 1, and then copying that to B. So that'll give us 1 and 1. Let's just check that. 1, 1, good. Then we want to copy our value, right? So we'll copy down the value. I guess they could give us. They're probably not going to give us 0 as a value. So we could just start by outboxing 1 twice. But before we think about that, let's think a little bit about how we're going to do this. So we're going to need a loop, obviously. And we're going to want to do the Fibonacci value. I think we're going to need another spot in order to do this. I think we are. Because if we add A and B to figure out what effectively C should be, then we sort of want to shift everything back, but we need to store C in order to do that. So I think we're going to make this C and make this our value. And we're gonna copy to B and C, and we're gonna copy to our value. So A is gonna be empty to start with, but that's okay because, is that okay? I can't tell if that's okay. No, I think we're gonna need to construct 2 as well. So I'll copy to A, bump to A, copy to B, copy to C and bump C. That should give us 1, 1, 2. And there's a nice infinite loop right there. I'm going to have to think more about this. But I think that is about going to do it for me tonight. It's getting close to 6 o'clock my time. So I want to thank everyone for watching who has been. This has been a pretty good first stream. I hope I've enjoyed it. I hope anyone who's watching has enjoyed it as well. Like I said when I started, I'd love to get into maybe, slightly more serious games that I enjoy playing recreationally, like a Formula 1, maybe a Euro Truck Simulator. I don't know that I have the hardware to stream those, so if I want to get into that, I may need to invest in a more gaming computer than what my home computer is. So we'll see if I ever get there. But for now, I'm appreciating, maybe smaller, less intense, graphically intensive games like this, and particularly ones that are, interesting to me from an intellectual perspective. So I may do some more puzzle games. We'll see. But for at least the near-term future, I would really love to. I would love to, keep exploring this game. Maybe get into some of the optimization, and definitely these harder levels are going to be a little bit harder to do. I'm probably not going to think about them too much in my spare time, just because I'd love to share that process of me working through it, in addition to just showing folks the game. And I definitely think that's true if I get into those more simulation style games. I feel the same way about those, that anyone can play them. But I think what's interesting to me is watching someone, even if they're not necessarily really awesome at those games, to watch them kind of as they're thinking through, as they're strategizing about how to play those games. I think that's as interesting as the gameplay itself. But that's all for tonight. I'm going to leave it there. So if you have been, thanks for watching.